Hello viewers. In previous lectures, we have seen about a basic introduction about the PLC. Today, I, Dr. Prashant Badgujar, lecturer in electronics, Government Polytechnic Ahmednagar, will be telling you about different blocks of the PLC. So let's see what we are going to see today. Our learning objectives are: after this lecture, the students will be able to explain block diagram of PLC along with its function. So there are various blocks of PLC. We are going to see each and every function of each block in detail. Also, you will be able to identify different IO devices to be interfaced with the PLC. And last, you will be able to describe memory organization in the PLC. So let's see how PLC looks like. In previous lecture, you have seen some basics of PLC. It is a controller which is used in industrial environment or a very harsh environment where the extreme temperature, extreme vibration, extreme pressure, like conditions are there, or it automate many kind of things. You have also seen various applications of the PLC. So let's see how PLC looks like. So this is one type of PLC of the Siemens company. These are inputs, these are outputs, and this is your CPU and power supply is there. So this is a fixed kind of PLC which you cannot extend its inputs and outputs. If we can extend the IOs of that PLC, then that PLC is called as modular PLC. So there is a separate CPU and separate racks are there in which you can mount the digital input, digital output, analog input and analog outputs. And along with this, separate power supply or combined power supply may also be given in the PLC. So this kind of structure or this kind of structure is a modular PLC, and this is a fixed kind of PLC which is a small PLC. So you can extend this PLC to the greater extent or as per the needs of the industry. What basically is there in the programmable logic controller? It consists of blocks like input module, output module, processor is there, program loader section is there, and every module is backed up with the power supply. So these are the major blocks of the programmable logic controller: input module, output module. Both in combination are called as IO modules, which are found at the field level. So in input module, we are getting the various information from the physical parameters, and these which are called as sensor, and these sensor convert the physical information into electrical information. The input module read those input signals, and it pass those electrical input signal to the processor or the CPU of programmable logic controller. So based on the logic which we have programmed into this CPU, the processor will execute the logic and it will give prepare the output signal. So the status of this output signal is stored in the output register, and at output module certain actuators are connected, so which will convert electrical signal into the your again physical signal which is required. Okay, so we are going to see what is input module, what is output module, how it looks alike, which are the functions of IO module, which are the sensors, which are different kind of actuators which we are using. Along with this, so this is the first module which we are going to see. Second module, processor, which consists of the logic section, memory module, power supply section, and various memories are there, how those memories are organized. So this is a second section which is also called as processor section or the CPU section. And third one is your program loader or program monitor section. From this section, you can load program into a processor, or you can take down that program. So these three sections are there which we are using for the describing the these kind of PLC. So all PLCs have same configuration. Little bit plus minus is there in that in that PLC. So it is based on the which configuration PLC we are selecting, or which vendor we are selecting for the implementation of the automation purpose. So this is the these blocks is are there in the PLC block diagram. So as I have told you, there is a IO section. IO section consists of sensors, input modules. So these are at the input side. So input module can be a digital input module or analog input module. Output module is there at the output side firstly, and at last actuators are there. So you are knowing the definition of sensor, actuator. Sensor are the devices which convert your physical information into electrical information. Input module, this will uh, con- uh, uh, take the input from the sensor and convert it into appropriate format which is required by the PLC. So what kind of format is required by PLC? It require 12 volt or 24 volt or 48 volt. So depending on the configuration of PLC, it convert it into 12 volt or 24 volt. So this is the minimum voltage required by the PLC. So this is the function of input module. Output module is there which convert 12 volt, 24 volt, 48 volt signal into the appropriate electrical signal required by the actuator. An actuator, you are knowing the definition of actuator. It is a device which convert electrical signal into physical signal. So we have to see all these in detail. So this is just the introduction. Second is the processor section. It consists of three uh, basic submodules: power supply, memory, and the centralized processing unit. And third section, third block of PLC is the program loader section. So this is the brief classification of the different three blocks of the PLC. So we will see all these sections one by one. So first one is IO section. So IO section established the interface between the environment and the PLC. So as I have told you, it senses the physical parameters and convert it into the electrical signal. So it take the signal from environment and give it to the input module of the PLC. So it is just the interface between environment and the PLC. So for this interface purpose, that these tasks are done by sensors and the actuators. Sensor senses the your signal, and actuators give output into a physical format. So during this means which are the major tasks which are performed by the sensors, actuators, and input module and output module. So basically four kind of operations are done on the on this particular signal. First one is the signal conditioning. So signal conditioning is that we have to convert signal into the appropriate format which is required by the PLC. So suppose a particular one sensor is sensing the temperature and converting it into the some kind of millivoltage, or we will consider it as in 1 volt, and the input required by PLC is a 12 volt. So there is no match between the 1 volt and the 12 volt. So we have to amplify this signal from 1 volt to the 12 volt. So this amplification of the signal will be done by the input module. Okay, so either attenuating the signal or amplifying the signal, this kind of things are done by the IO cards. So the signal condition activity is done by the IO module. Second, the signal can be indicated. If the sensor's output is giving some voltage, 1 volt, 2 volt, some millivolt, microvolt. So whether signal is arrived at the uh, input of the input module, that is given by the sensor and which is available at the input module. So whether it is there or not, or if output is calculated by the processor, so whether output is calculated by processor or not, so this is indicated at the input card or output card, input module or the at the output module. So this is indicated with the help of IO module. Third one is a terminate. So in this, IO module provide proper termination of input and output connectivity of the terminal so as to avoid any direct AC supply with the PLC. So it will terminate all unnecessary signals and it will uh, provide a protection to your PLC. And fourth one is a isolation. So it just like your relays, PLC input module and output modules are acts as a isolation device. So input output modules consist of, there are some optocouplers are there, and with the help of optocouplers, if very low signal or very high signal is present at the input, so that is isolated from the 12 volt or 24 volt of the PLC. Okay, so it will protect from the PLC from the various very low input or very high input or surges or any kind of errors. Okay, so for isolation purpose we can also use this uh, uh, IO modules. Okay, so these are the four functions: signal conditioning, which include amplification or attenuation of the signal, indication of the signal, termination of the signal, or isolation of the signals. These four important functions are done by the IO section. Okay, so in IO section, what is the sequence of this IO section? Just remember this. Firstly, sensors are there which will sense the signal, convert signal from physical to the electrical format. At the second place, input module is there. Input module, it convert analog signal into a digital signal uh, and amplify it into the appropriate format by using analog card, or digital signal is amplified or attenuated to the required form. Okay, so second block is your input module, then processor is there, so which is not a part of IO section, and then output module is there. Output module will read whether the output is calculated by your processor or not, and by using digital or discrete card or analog card, the signal will be converted into appropriate format which is required by this your uh, actuators. Okay, so first is sensor, second is input module, third is output module, and fourth one is your actuators. Okay, so these four things, or these four individual submodules are included into the IO section: sensor, input module, output module, and your actuators. Okay, so these are the basic function, four basic functions of the IO section. We will see what sensor or what input devices we use or we interface with your input module. Okay, so there are different kind of sensors are there. There are n number of sensors, but uh, at priority or generally we use these sensors, which include, there are various limit switches So limit switch looks like this. So whenever some displacement is there, so this switch is pressed, and we can get out electrical signal at the output of this uh, limit switch. Photoelectric sensors are there which will sense the intensity of the light, and based on the intensity of the light, appropriate electrical signal is obtained. Proximity switches are there, pressure switches are there, which will sense the pressure of a particular uh, parameter, and it will convert it into the appropriate electrical signal. Level switches are there, which are always used in tank level control or measuring well, some for measuring some levels of the particular fluid or liquid. Temperature switches are there, vacuum switches are there, float switches are there, optical encoders are there. So these are some pictorial input devices shown with the help of pictures. So this is a switch, on off switch or push button. So this is also push button. This is a selector switch, which you can see in your fan regulator. So whenever we will press this selector switch, so speed of your fan will increase or decrease. Okay, so as we are able to select various drops by using various resistances arrangement, you can change the output voltage at the output of the sensor. So this is a thermocouple. Thermocouples can be of K type or N type. Okay, different type of thermocouples are there which we can use. This is a rotary switch. Then this is a speed motor sensor which will sense the speed of motor and it convert it into the electrical signal. Limit switch we have seen. Timers are also used as input devices. Then this is a photoelectric switch, uh, a rotary encoder, and proximity switch. Okay, so likewise there are many sensors are there. You can see different type of sensors in this diagram. So all these are sensors uh, which we have seen in depth. Then second sub module in IO module is input modules. Okay, so if your PLC is a modular PLC, means whose inputs and outputs which you can increase or decrease, that kind of configuration is there. In this case, you can see this is a input card, discrete input module. Okay, so which is used to sense different DC or discrete signal. So you have seen this PLC. So this is a input card which you have to mount in the rack of the PLC. Okay, so this kind of digital analog cards maybe you can use. So if you will open the this cover, then you can see this is a contact of the relay, normally open, normally closed contact. So by connecting to normally close, you can connect the supply, and this NO you can connect your another terminal of the your actuator or sensor or any kind of device. Okay, so by you can do the connection to the this input relays of the PLC. So these relays are different from your electromechanical relays. Okay, just understand the difference between the PLC relay and which are solid state relays, and the old normal electromechanical relay. So we have already seen the advantages of these solid state relays in your previous lecture. Okay, so these kind of relays are there. I will also show what is there in inside the circuit of this card. So like this, the input cards can be our inputs cards are there, and this is a analog input module. Okay, so it looks same as that of your discrete input module. Only difference is that it will convert analog signal into digital signal firstly, and then digital signal is processed, either amplified or attenuated, and then this signal, 12 volt 24 volt signal, is given by the communication wires to the PLC. Okay, so both cards are same, circuits are also almost same, they also look same. So if you will open this cover, then you will be you will find this kind of solid state relays are there inside this. And beyond that, this is a plate which is consisting of different electronic circuits. Okay, just difference is that analog input module will firstly convert analog signal into digital signal, and then it will process the signal just like a discrete input module. Okay, so these are the internal circuits of your discrete input module and analog input module. Okay, so as you can see, this is the micro PLC IO card, DI board. So maybe it is a 8 or 16 bit digital input card. I have just taken the random image from the internet. So you will not get what is there inside, means what these basic blocks are there, as it is a integrated circuit. So the signal from these relays is connected over here on the board, and this board will process signal through these various blocks, and it will give output at these terminals. Okay, and PLC will read the input from or the signal from the uh, these terminals. Okay, so as you can see, this is having a lesser circuit as compared to this analog input module. The reason I have told you why, because the analog signal must be converted into the digital signal. Okay, so just for that purpose, so that's why the cost of analog input module is also the higher than your digital input module. Okay, so this is a 4 analog input uh, card of the PLC. So this is indicated on the card. Okay, so the input module, whether it could be discrete input module or analog input module, these they are look like this, and on the board, means over here, the circuit is actually, so the sensor, various sensor, hand switch, pressure switch, or any other kind of sensor is connected to this is actually a input card, discrete input card, and it is given to the input of the card. So here there are some relays, solid state relays of the input card, and to these relays, so this is the connection of the relay, and it is given to uh, this is a optocoupler. So whenever signal will come over here, the diode will emit the light, and it will fall on the phototransistor, and based on the biasing, the current will flow and signal will be given to the processor. Okay, uh, so if a very high signal arrived at this input, so at that time, because of this light or the optocoupler, the this part of processor will be protected from the this part of the input card. Okay, so like this, you can save the processor of the PLC by using the isolation function of the input module. Okay, so this is the internal diagram. Now we will see third sub module of the IO section, that is a output module. Okay, so how output modules look like? So they look like same like your discrete input module and analog input module. Okay, so by nature, by looks, it look same as that of previous input modules, just the internal circuits are different. Okay, so if you will open this cap, again this cap, then again you will find these uh, solid state relays are there. So the signal from processor will be connected to the these terminals. So this circuit will process that 12 volt 24 volt signal, convert it into the appropriate form, and by using these output relays, the output is taken by the actuators. Okay, so discrete output module is same as that of analog output module. Only difference is that analog output module will convert discrete signal obtained from processor, processed by this card. It will convert that signal into the analog format. Okay, so that's why this is the name given, analog output format. Okay, so analog output module is just the combination of discrete output module plus digital to analog converter. Okay, so how these cards looks like. So this is a discrete digital output board, discrete IO card. So maybe it is a 16 8 or 16 uh, output, discrete output module. So this signal will be received, given by the processor, and that signal 12 volt 24 volt will be converted to the appropriate signal using this circuit, and it will be obtained at these terminals. So this is a discrete output model, and next one is the analog output model. So processor will give a signal at these terminals, and it will be processed, and it will be converted into the analog format using DAC. Okay, so these ICs will do that function, and the analog signal will be obtained over here. Okay, so this is a two channel isolated sourcing syncing combined voltage and current analog output module by the Texas Instrument Company. Okay, so this is the just internal circuit of this output module, and in just reverse way, this output card will function. So there is a the signal will be given from processor to the optocoupler. So whenever signal will come, it will fall on the track, and it will amplify, attenuate, or means in the required format the signal will be given, and may be some driver circuit at the output, which will turn on your lamp, motor, fan, or any kind of actuator. Okay, and fourth one is your actuator or the output device. Okay, so which actuators are there? Control relays, horn, alarms, stack lights, fans, counters or totalizers, pumps, printers, buzzers. There are many actuators. So this is the motor, symbol of motor. Solenoid valves are there. LED displays are there, which can act as a output device or actuator. Heater, lamp, motor starter. This is also example of motor starter. Relays. So based on the specification, the size and various configuration of PLCs may differ. Okay, and these are some fans. Okay, so these are the actuators which you can use. Okay, so these are the four modules, sub modules, which are included in your input output section. Next is processor section. So it is a second section, which its block diagram, which you can see there is one centralized processing unit. So then it is having address bus as well as data bus. So what is the purpose of these buses? These buses will carry out the signal to the memory and from the memory for the purpose of the processing the data. Okay, so from where this data will come? Data will come from the IO input output interface. Okay, so from input module we will get the data, and the processed data will be given to the output module. So these four memories will play a very important role in your processor section. First one is IO memory, input output memory, then user or memory or ROM, uh, then internal memory or RAM, and execute memory. Okay, so these four memories are there. We will see all these in detail. And there is a power supply providing mechanism. There is some communication interface. So by this communication interface you can load a program into the ROM. Okay, so program loader section will come into picture over here. So we are going to see it differently in third section, and some timers, counters kind of functions may be there in your CPU. Okay, so as you have seen, it consists of three parts. First one is power supply, second one is a memory section, and third one is a CPU. Okay, and there is some interfacing kind of thing between these three: power supply, memory, and the CPU. So in processor section, first one is a power supply. So our power supply is just similar to our uh, power supply which we use in any kind of circuit. So it consists of, there is some transformer which convert 240, 120 or any kind of voltage into the appropriate voltage. So we will assume that our PLC is of requirement 24 volt DC. Okay, so this 12, 24, 36, 48, these are the ideal voltage requirement or the specifications of your PLC. Okay, so maybe the 18 volt, 20 volt, it will convert input signal into some 18, 20 volt. There is a bridge rectifier. So in positive half cycle, two diodes, and negative two diodes will work. Okay, so this is a rectifier section. Then the rectified voltage is converted into the unfiltered voltage by using a capacitor, and then by using some regulator IC you can get the output voltage. Okay, so this will be the regulated DC voltage. Okay, so the arrangement of power supply is similar to the previous which you have learned, but in PLC what happens, the processor and the power supply, those are very together, and it should not happen that the power supply will get short circuited, or there should not be trouble to the processor section. So we have to take care of this. The power supply must be properly designed. What will happen if the power supply will get damaged? Then the PLC will stop the working, and industrial production will get hampered, and we will be in a huge loss. Okay, so that's why power supply must be designed very, very carefully. Okay, so just for that purpose, what guidelines we should follow while designing the power supply? So first is, you should it should be packed properly to prevent it from overheating. Okay, so if the power supply will get heated, it will affect the performance of CPU, and it will affect the production. So it should not, or it should prevent the power supply from the overheating. Then second care you should take, it should be tested for temperature and electrical insulation by the proper certification. So this is mandatory. You should go for some ISO or ISI kind of certification, just to ensure that your power supply is working in very good at all temperature, and the electrical insulation should be very good. Third guideline for this power supplies, it should meet the standards for the noise immunity. Okay, and last one, preferably redundancy should be used to increase the reliability. What is the redundancy? Means suppose our power supply will get fail today. So uh, what we can do, either we can replace or we can do the maintenance of that power supply. So meanwhile, there would be lot of time consumed and our production may get stopped. Okay, so in order to avoid this situation, what we have to do, we will keep another power supply just in parallel with the existing power supply. So is it necessary to keep that power supply? No, but in case of failure of current power supply, the parallel power supply can be immediately connected and your power supply can be sent for the maintenance purpose. Okay, so that's why we should keep this redundant, or which power supply which is not in used in parallel with the existing power supply, which is also called as the redundant power supply. Okay, so to increase the reliability of your production, we should preferably use a redundant power supply. Okay, so these are the guidelines for the designing the power supply. Then second one is your processor. In processor section, second one is your memory section. Okay, so you know that memories are of two types. First one is a volatile memory. So what is volatile memory? In volatile memory, uh, the content written in the memory will get erased when the power supply will go off. Okay, so its validity of that data is only for the cycle for which your power supply is turned on. Okay, and there is another memory which is called as non-volatile memory. Okay, so non-volatile memory, you know that this memory will not get erased even if the power supply will fail. So whenever you will switch on the PLC after whenever power will come, so whatever currently processed data will be as it is. Okay, so these are two types of your memories. Volatile memory, example of this volatile memory is RAM, randomly access memory. Okay, and non-volatile memory is your user memory or ROM. So in PLC, we generally use battery backed up CMOS RAM. It is a volatile memory and it consumes a very small amount of power as it is made up of CMOS. The space required and power required is very less. The batteries are used will retain the energy during the power loss, and batteries can be replaced after some 6 months to the years. Okay, so this is the RAM which we use in your. So which are functions of this RAM? It will store the program related to radar diagram, numerics, functional status, and IO status into it. So the information will be read and stored temporary in this RAM, and it will also store the user programs which are taken from the user memory or the ROM. Okay, so it will speed up the operation of your any kind of work or calculation. So this is internal memory or random access memory in your PLC. So now another memory which is which you can use is ROM. Okay, so you know that ROM has two types, EEPROM, so and EEPROM. Okay, so first of all we will see what is this EEPROM and EEPROM. EEPROM means it is a electrically programmable read-only memory. You can program into this memory by using electrical signal, but to erase this memory you have to apply ultraviolet light. Okay, so this may not be possible every time, so that's why these memories are not used. And second one is Second one is EEPROM. EEPROM means electrically erasable programmable read-only memory. So it is similar to EEPROM. So just to write in this memory, you have to apply a programming voltage, and just to erase that written data, you have to again apply the electrical signal or the some erasing voltage. Okay, so it will avoid this ultraviolet light kind of thing to erase this data. Okay, so this EEPROM will provide more flexibility while the reprogramming your devices. Okay, so these memories are divided into internal RAM, user memory, that is also called as ROM, IO memory, and the executive memory. Okay, so we have seen the function of internal memory or RAM. We have seen the function of ROM. In that we have seen EEPROM and EEPROM. So what is function of this IO image memory? So it will store the status of input or output in your input module or output module. Okay, so whenever input will be arrived, will be captured by sensor, then this IO memory will store that there is a input arrived. So the flag which you can see, or you can see the LED is glowing at the input module of the PLC. Or if the signal is stored, processed by the CPU, and output is calculated, it will again send the data at uh, your input output image memory. So in this, output bit will be turned on, and at the output card you can see the LED is blinking. So it will indicate that your output is ready, calculated, and you can read it from this output module, and the actuators will read that output. Okay, so it will just store the status of input, whether input is arrived or not, or status of output, whether output is arrived or not. So this is your IO memory, and there is a executive memory. So this executive memory will hold the executive software. So whatever PLC software is there, you can use this PLC software which is stored in the execute memory. Okay, so these four memories are there in the memory section. So this is the organization of these memories in the PLC. So firstly, which memory is there? There is a user memory or RAM. Below that, input image status and output image status. That is a IO memory is there. Below that, there is a timer status, counter status, numerical data, other functions. So likewise, the memory is organized in your PLC. Okay, so there are different kind of representations are there. Different manufacturers uses a different memory organization. Okay, so this is just the sample. In many books you can find the different kind of organizations. All those are correct. Okay, so I would suggest you should follow this memory organization in the PLC. And third section in your processor section, it is the CPU, centralized processing unit. So you know that CPU is the heart of PLC, and all major functions are performed by the processor. So it is a heart of the PLC. It perform which functions? First it perform the control function. It monitor various activities. It supervises all the PLC operations. Okay, so the functions of this CPU are: it store the input output data, into the data memory. So this is the first function. Then it execute the program using execute software in the execute memory and the logic which we have written in the ROM. Okay, it execute the scan cycle. So what is the scan cycle? It will continuously seeking the inputs. If inputs are arrived, then it will process those signals. After processing, it will turn on the output status, and if output status is existing, it will give signal to the actuators. Okay, so we are going to see this scan cycle in detail later. So just remember that it consists of input scan, processing the signal, output scan, and the final diagnosis of the uh, system. And last function is the self diagnosis. So it will take care of all peripherals of the PLC: input module, sensor, actuators, output module, power supply, as well as the processor will take care of its self management. Okay, so it will there is some predefined program in the execute memory which is responsible for the diagnosis of the PLC. Okay, so this diagnosis will be done by self PLC. Okay, so these activities are carried out by your CPU. Functions it control, monitor, and supervise the PLC operation. So these three activities are done by your CPU. So it operates in three major modes. First one is a programming mode. So in programming mode, what CPU will do? Nothing will be functional. Only we can connect the external PC or device to the CPU, and you can load program, user program into the CPU. Okay. In the run mode, second mode is run mode. In run mode, what happen? You cannot program the PLC, but whatever program which we have written in the program mode, that program will be run by the PLC. Okay, so in programming mode, other modes will not work. In run mode also, other modes will not work. Okay, and third mode is the remote mode. So what is remote mode? If suppose my PLC is in one plant and I want to operate this PLC from the another plant or the another country. So in this case, what I have to do, I have to switch this PLC into remote mode from the run mode. Okay, so in remote mode, you can operate this PLC, program this PLC, or whatever can be done in the remote mode from the remote place. Okay, so REM mode, it is called as. So it is a remote mode. Okay, so different CPUs are there in the PLC. So how to select this CPU? That could be the question in your mind. So uh, just select appropriate PLC, a small, medium, large, or any kind of PLC. What you have to look? You have to look the flexibility of the CPU. Okay, what is the flexibility? If suppose I have started the plant at some smaller scale, but later a demand of my product is increased and I want to increase the production, so it will require some additional machinery, and just to run that machinery you will require additional input and output. Okay, so but if I have selected the fixed PLC, then I would not be able to increase the capacity of that CPU. So what I will do, I will just uh, while purchasing PLC, I will just purchase a PLC with the modular nature. Okay, so in which I can insert input output cards and input output capacity of the PLC. So CPU will be same, it will just increase the input and output of the PLC. Okay, so if it is flexible, then we can use same PLC in the higher production as well. Okay, so flexibility you have to look. Then speed of the PLC, what is application? We require medium speed or small speed or higher speed. Then the scan cycle and other additional functions like a timer, counter, and various other functions are there or not. What is the input output capacity of my CPU? Okay, so these are many criteria which you have to look while selecting the CPU. Okay, so this is the second processor section, and third one is the program loader section. Okay, so we can load program into the PLC. So this is a one fixed PLC. So program can be loaded into the PLC by using two devices. First one is a HHT. It is also called as handheld device, which you can see it looks like some multimeter or calculator. Okay, so by pressing these buttons you can select appropriate command, which also you can also see this command over here, and these commands are can be sent to the CPU of the PLC. Okay, so this is a handy device. You should have some practice on this device so that the program can be burned. So where this HHT is used, the place where it is not possible to carry out the PC, wherever there are extreme conditions are there of the temperature, pressure. At that place you can use this handheld device. Okay, so it is a portable device, and another option is by using PC. So software is loaded into the CPU of PC. You can see this software on the monitor. You can enter the program into this PC, and in by running PLC into the programming mode, you can send program from PC to the PLC. Okay, so this is the program loader section, from which you can send the program into the PLC by using HHT or by using the PC. So this is the PLC which we are having in the lab of instrumentation department. Allen Bradley PLC we are having 16 input, 16 in digital input, 4 analog input. Uh, Sorry, it is not 16, it is a 8 digital input, 4 analog input, 8 digital output, and the 4 analog output. Okay, so this configuration is there in our lab. Okay, so these are the basic of the PLC. What blocks are there in the PLC, and this is the this anatomy we have seen in this lecture regarding the PLC. Thank you.